All right, if you have not written these down yet, you will want to have these in your notes, each of these properties. Again, this first one says that we're allowed to add the same number to both sides of the equation. The second one says we're allowed to subtract both sides by the same number. The third one says we're allowed to multiply both sides by that number. This division allows us to divide both sides of an equation by the same number. Reflexive is when you have something equal to itself. Symmetric is when you have two things that are equal and you're allowed to swap sides. They can trade sides and it's okay. Transitive is when we take a string of equations and put them together because we have this middle term repeated. So if A is B and B is C, well, we can just cut B out then, and then A and C would have to be the same if they're both the same as B. And finally, the substitution property. If A and B are the same, you can substitute A for B in any expression you come upon. Again, you need to have those in your notes somewhere. All right, let's try and use some of those. What's the justification for this conclusion? We were given that angle PQR was congruent to triangle ABC. We were then given that ABC was congruent to LMN. They concluded then that PQR would have to be equal to LMN. So what they did here is they said, okay, if PQR is the same as ABC and ABC is the same as LMN, we can cut out this middle guy ABC and just have PQR and LMN being congruent. Which of our properties was that? Which of our properties? Okay, again, go from this list of properties. Which of those tells us? Well, if you look down here, our transitive property allows us to do that. Okay, so you'll just want to work with these examples until you recognize them. Okay, how about this example? What property justifies the statement that the measure of angle 1 is equal to the measure of angle 2? This is one of our properties of geometry. Do you recognize it? We did it earlier in the course. What tells us that two angles across the intersection from one another are congruent? What kind of angles are those? Okay, again, I'm bringing this one up because we will use this in proofs a lot. Remember that those are called vertical angles. And depending on which textbook or which course you use, they may state it differently. But basically the property that allows us to know that is that we have a definition that says vertical angles are congruent. So that is why we are allowed to do that. They may say definition of vertical angles or just vertical angles are congruent. The reason angle 1 and angle 2 were congruent in this picture is because they were vertical angles. That would be our justification. Identify the property that justifies this statement using this picture. How do we know that AB plus BC equals AC? What property, what definition tells us that? Again, this is from earlier in the course. What tells us that the line from A to B, if we take that, okay, let me put some numbers in here. Maybe that will help illustrate. How do we know that if, let's say this is length 2 and this is length 8, how do we know that from A to C would be 2 plus 8? I think when we look at that, we can say to ourselves, yeah, that's true. But why is it true? Do you remember the name of the property that allows us to do that? To take two segments that are next to each other, add them together to get the whole thing. Well, I made a smiley there. Right? If you don't remember, I will tell you. When you add two segments together to get a bigger segment, that is called the segment addition postulate. Again, that's one we will use as we do proofs. All right, here's another one. What property allows us to say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle PQR? Now notice PQR is this big angle here that goes from P to Q to R. It holds angle 1 and angle 2 inside of it. What property tells us that if I add angle 1 to angle 2, I get the measure of the angle that they are inside of? Okay, that property would be the angle addition postulate. The angle addition postulate tells us when we have two adjacent angles, two angles that are touching, and combine to make a bigger angle, we can add their measures together to get the measure of the whole thing. Okay, so for example, if we knew that angle 1 had a measure of 30 degrees, and angle 2 had a measure of 40 degrees, and this kind of looks like common sense, but it's using the angle addition postulate. We would know that angle PQR, so this angle going from P down to Q out to R, would have to be those two put together. It would have to be 30 plus 40, or angle 1 plus angle 2.